the supervision of basketball. Our group focuses on newly emerged crystalline material called metal organic fragments. So, MOFs. MOFs have tremendous large surface area. If we can unfold 1 gram of MOF, we can cover area of one entire football field. In the ultra high porosity, large surface area, they have got the attention of many researchers around the globe for various kind of applications such as gas storage, separation of gas molecules, chemical sensing, much more. We are currently working on separation of hydrocarbons. Hello students, I am Yogesh Soni. This laboratory is funded by Department of Science and Technology and Science and Engineering Research Board India to develop magnetic field based paper diffraction rating. Here in this laboratory, we are working on the optical properties of magnetic field, such as magnetic field induced light transmission, birefringence, Faraday rotation, refractive index, and microscope. We are also working in the other applications of magnetic field in optics, such as adaptive liquid lens and tunable mirror. We are also working on optical clocking, in which apart from that, we are also working in the biology sector. Well, this magnetic nanoparticles can be useful to extract protein from the biological cells.
And I am doing my PhD at P.D. Patel Institute of Applied Sciences, and I am doing my PhD under the guidance of Dr. Palash Mandal. We have different facilities in our lab, and basically we are doing research on alcoholic liver diseases and non-alcoholic liver diseases in our lab. The facilities which we are having in our labs are including qPCR, homogenizer, electrophoresis, PAC, etc. Hello everyone. Yes, ours is a DST funded research laboratory where we use various biochemical as well as molecular techniques to understand mechanisms underlying plant based post microbe interactions and genetic engineering. Various facilities are available in the lab to support the research. These facilities include using visible spectrophotometer, PCR thermocycler machine, as well as sonicator, to name a few. Myself, Samini Om Prakash Charan, working as a research scholar at Department of Biological Sciences in P.D. Patel Institute of Applied Sciences. Present in the Common Research Biological Lab is bioreactor, which is of bioengineering KLF-Me. The bioreactor is being used in producing the products which are useful for industrial purposes and industries. The targeted product which we produce using bioreactor is probiotics, antibiotics, exopolysaccharides, biopolymers, etc. Patel, working as a research student under the guidance of Dr. Abhishek Dadania. Using zinc, cadmium, and cobalt metals. Functional nature of metal rotation frameworks helps to find potential applications in various fields such as gas storage, membrane, thin film devices, adsorption, separation, and catalysis, heterogeneous.
University of Science and Technology cultivates mind, body, and soul through academic excellence, competitive sports, and That is Charesan. It's a beautiful name the university has. And today the nation needs golden. Faculty of Applied Sciences. Breaking grounds for future of applied sciences. PD Institute of Applied Sciences. Shri P.D. Patel, CMD, Emirates Transformer and Switchgear Limited, Dubai, and his family has facilitated the establishment of institute. Donated 40 million rupees. The institute offers BSc in Biological Sciences, Physics, MSc in Microbiology, Biochemistry, Biotechnology, Advanced Organic Chemistry, Physics, and Mathematics. PhD in various disciplines of applied sciences. Hello, am I audible?
Yes, sir.
So today we are going to start with session of mathematics. So first candidate is Dharti Gosai. Do we have Dharti Gosai on platform? Yes, sir. Okay, fine. Yes. Now let's start your presentation. Okay, sir. Can you see my screen, sir? Yes, yes. You can start. Okay. Hello. Hello. Hello, sir. Dharti. Dharti. Okay. Dharti. Yes, sir. You can start. Okay, sir. My screen is visible, sir? No, it's not visible. Okay. Now it is? Yes. No, no, it is not visible. Not visible? But still it is not visible. Yes, now it is visible. Okay, sir. Good morning, sir. Hello, everyone. Myself, Karti Kosai, and my talk on fractional viscoelasticity. First of all, what is the meaning of fractional? Fractional calculus means a derivative and integral of arbitrary order or real order or complex order. And then once L Hospital asked that what if we take order n equals to 1/2 or zero point 0.5 of order of derivative? Then is this any answer, any solution, any interpretation? Then the Leibniz told that it is called fractional derivative. If we take the order of 1/2 or any 0.5, 1.2, and it called the fractional derivative. And the answer Leibniz gave that answer on 13 September. So that the 30 September is considered as a birthday of fractional calculus. And some moving from some mathematics of fractional derivative. Mainly there are two fractional derivative, Riemann-Leibler and Caputo derivative. First, the Riemann-Leibler fractional derivative. The definition shows the RL fractional derivative and the second derivative of capital fractional derivative. This definition shows the capital fractional derivative. Then moving from the topic of viscoelasticity. What is the meaning of viscoelasticity? First of all, some material follows both behavior like elastic and viscous. They called viscoelastic material. Like we can give example of shampoo, rubber, glues. Now we moving. There is mainly two model, Voigt model and Kelvin model to find the viscoelasticity of material. And we are moving from the fractional viscoelastic model. The idea of fractional viscoelasticity model is approximation of materials behavior that order of derivative of a strain. Now, what is the meaning of stress and strain? Stress means it is a physical quantity that in material there is the internal forces between neighboring particles, and strain means the deformation of material. Then suppose if we take first order of viscous fluid, and zeroth order of elastic solid, then the viscous material occupy the range between 0 to 1, called the fractional order of alpha, which means the range of alpha is between 0 to 1, represent the viscoelastic material. Now moving to the models. Here I am taking only one model, Kelvin-Voigt model. Then this model represent by the spring and dashpot in parallel. Given in figure, the figure of Kelvin-Voigt model. Here E represent the spring and this is the dashpot. Then this equation, this relationship gives the normal Kelvin-Voigt model. Here the sigma represent the stress and epsilon represent the strain, and Q0 and Q1 is parameters. And after determine this relationship, we can find that अगर हम इसका इस इक्वेशन को डिटरमाइन करे सॉल्यूशंस होते तो उससे पता चलता है कि वी कैन फाइंड दैट इन दिस मॉडल does not retain any time history or memory effect. From the simulation we can find that कैल्विन मॉडल में कोई टाइम हिस्ट्री और मेमोरी फीचर्स कंसिडर नहीं होता. Then the idea we can overcome this problem by applying fractional Kelvin model. If we can show, we apply fractional derivative on strain. Here we can show apply fractional derivative on strain. Then thus from simulation we can get much better result of Kelvin-Voigt model. By the simulation from this equation we get uh, much better result from the normal Kelvin-Voigt model. So in general, my conclusion is that the fractional model do a better job of capturing the real behavior of material over wide frequency range. Thank you, sir. This is the references papers. Okay.
Hello.
Yes, sir.
Hello.
Yes, sir. Hello.
What is the difference between demand evolution derivative and capital derivative?
Okay. Here we are taking in Riemann level. Here we are taking first the derivative of the gamma function, and then the integral of any function which we can get taken. And in capital, first we take integration of a function, and then derivative of which we can apply in function.
What is n here? What is n?
Sorry, sir.
What is n?
N is the first order. The nth order. And alpha is the fractional order.
What is the viscous fluid?
Viscous fluid means we can take the example like water. We can say the water is a viscous fluid. That means if we called in the definition that neighbor internal force is almost zero between two particles.
You have represented this Kelvin model. What is Kelvin model? Sigma equal to Q 0.
Yes.
Put in the slide, please. This one, yes.
Sorry, sir.
What is epsilon here?
Epsilon represent the strains.
You have written the epsilon dash. What does it mean?
Epsilon ends with the derivative of epsilon, strain. Normal derivative.
What is epsilon?
Epsilon is strain, sir.
What?
Strain. Deformation of any material. A type of physical quantity, that deformation of any material.
It is a function of what? It is depending upon what?
Sorry?
It is depending upon some variable?
Yes, sir.
Which variable?
Time.
Time. Okay, thank you.
Yes.
Sir, very good.
Okay, sir. Thank you. Can I stop sharing my screen?
Thank you.
Okay, sir.
Yes, sir. Okay, sir.